Okay, so today we're going to look at a quick review of what quadratic functions are. And what you're looking at in front of you should be the exact same PDF file that you should have found under your Blackboard number 4 folder in your Blackboard Assignments tab. And today what we're looking at is 3 different forms of quadratic functions that should look familiar to you. And off to the right-hand side is the quadratic graph that actually represents all 3 of these forms that are part of this first example. So what I did is I wrote the equation of this quadratic function in the 3 different forms that we're going to talk about today off to the left-hand side, just to show you that the 3 different forms, while they look different, actually give you the same graph. So I'm going to start off. I actually wrote up some notes here. They're a little bit different from the notes that are on the PDF, but they're there for you. So it's just kind of an added support as we go through and start reviewing these quadratic functions. So the very first form that we're looking at is called standard form. And you know that you have a quadratic function in standard form when you have the equation that looks similar to y equals ax squared plus bx plus c. So in this case, the a, b, and c are all going to be constant values that are going to have some type of meaning that we'll talk about in just a couple minutes. But standard form, the real way that you can just figure out if you have standard form is if you have your x squared, which is your leading coefficient, your leading degree, all of that kind of fun stuff out in front first. So here in the first form, the first example, we have y is equal to x squared plus 2x minus 3. So we know we have a quadratic function in standard form. So when we have a quadratic in standard form, there's actually a few steps that we need to take in order to be able to graph that quadratic function. So the very first step that we have for graphing a quadratic in standard form is we want to find our axis of symmetry. And our axis of symmetry is the line that divides our quadratic function so that it's symmetrical on both sides. So in order to find the axis of symmetry, if it's in standard form, we do that by the equation x is equal to negative b divided by 2a. And that x value is going to have some importance in just a minute, but that negative b and a value are important, and they're given to you with this general form for the standard form equation. So with our given quadratic function, we know that our a value is going to be 1, our b value is going to be 2, and our c value is going to be negative 3. Now in this case, we don't need our c value down for the axis of symmetry, but we do need our b value and our a value. So plugging in what we know about a and b, we know our axis of symmetry for this standard form equation is going to be negative, with this negative, 2 divided by 2 times a, which is 1. That gives us negative 2 over 2, which we know to be negative 1. So our x value is equal to negative 1, and that's our axis of symmetry. So what does that mean? That means, and I have a couple other steps here, but I'm going to slide this all the way up and show you my little graph on the bottom. Don't worry about that step 3 just yet. But our axis of symmetry we're given is x is equal to negative 1. And what that's going to be is a vertical line going through the point x is equal to negative 1. And that's going to be our vertical line that's going to separate our quadratic graph, our quadratic function that we're going to graph in just a minute. So once we know our axis of symmetry, our step 2 is to find our vertex. And if we all remember, our vertex is actually that lowest point or highest point of our quadratic function. So to find our vertex, we know our vertex is going to fall on the axis of symmetry. Okay, so that vertex is going to fall on the axis of symmetry. So we already know our x value on that axis of symmetry. We know x is equal to negative 1. So we have to find what our y value is going to be. So in order to find out what our y value is going to be, we're going to plug that x value into our function, our original equation, to get our y value. So we're going to plug negative 1 in for x we're going to plug -1 again in for x, minus 3. So we're taking our original function, which is all the way up at the top, and we're plugging in what we got our axis of symmetry for x to be, and we're plugging it into that standard for the original function that we were given, our standard form that we were given for this example. So if we plug that in, y is equal to -1 squared is 1. 2 times -1 is minus 2, and then we have minus 3. So if we crunch those numbers, 1 minus 2 gives us -3, minus 3, oh, I'm sorry, 1 minus 2 gives us -1, minus 3 gives us -4. So y is equal to -4 when x is equal to -1. So what this tells us, if we write these two values in our ordered pair, x we know is -1, and when x is -1, y is -4. So we know our vertex should be at the point -1, -4. So if I slide this back down to where my graph is, I know my vertex is going to be -1, 1, 2, 3, 4. And I know that's going to be my vertex. Okay, so moving on, our step 3 is we need to find one other point on this graph. So we have our axis of symmetry, we need to find out, or we have our vertex, we need to find one other point on this graph. Because it's symmetrical, we know if we get one point on this graph that we'll be able to find a third point for free, basically, because of how quadratic functions are symmetrical. So if to find one other point on the graph, I'm going to go back and get my original equation for this quadratic. Typically, if our axis of symmetry isn't on our y-axis, we can actually use 0 as a really easy number to plug in to find out the other point, or another point, I should say. So if I plug in 0, y is equal to, and I plug in 0 for x, I get 0 squared plus 2 times 0 minus 3. 0 squared is obviously 0. 2 times 0 is obviously 0. So y is equal to -3. So I get the point 0, -3 as one of the points. So obviously I have my vertex now. I have one other point, which means if I'm 1 to the right of my axis of symmetry, I can go 1 to the left of my axis of symmetry. And I can connect the dots, and I get the graph that represents what this quadratic equation is. And if you look back on your sheet for the review of your quadratics, that graph that I just drew and the one that was given to you originally on this review sheet should match up perfectly. So that should be the graph of this standard form. The other two forms come in pretty easy after that. Obviously, the vertex form and intercept form are very different. Vertex form, you know you're in vertex form if you have parentheses with an x value inside that's raised to the second power. So you know your vertex form because it's going to have this type of standard look to it. Vertex form is really nice because you obviously get your vertex right away by looking at your vertex form. And how that always works is your vertex is always going to be your x value. I should write this out, x and y. But your x value of your vertex is always going to be the opposite value inside your parentheses with your x. So since I have a positive 1 here, I know that my vertex is going to be -1. And vertex for my y value is going to be this outside number as is. So the symbol or the value out in front never changes. So since I have a -4 on the outside, my y value here is going to be -4. So if I just kind of sketch this vertex form off to the right-hand side, what I know from my vertex form is that I have a -1, -4 as my vertex. What I can get now from the fact that I have a vertex at that point is because my vertex is there, I know that my axis of symmetry has to go through that point, has to go through my vertex. So I know my axis of symmetry is going to be through the line x is equal to -1. And I know that because I know my vertex is -1, -4. From here, I just need two other points to plug in. Just like I did with my standard form, I can pick any point that I possibly would want. If I plug in 0 to my original to find one point, I would get y equals 0 plus 1 squared minus 4. So this would give me 1 squared minus 4. 1 squared is obviously 1 minus 4, which gives me -3. So I know I have the point 0, -3. 0, 1, 2, 3 is one of my points on my graph. And because I have one point on my graph, I know I get for free my second point, which I should probably write down. That second point is going to be -2, -3. So I get my vertex point, my one point that I plugged in 0 for, and then my little freebie point. And again, if I take my graph, connect those dots, I'm going to end up with the same quadratic graph that I have on my original sheet for my notes. So they're going to match up identically. The last form that we're going to talk about is called intercept form. An intercept form is given to you in two separate brackets. You're going to have one pair of parentheses, a second pair of parentheses, both with your x leading. And the nice part about your intercepts is that if we set them equal to 0, they're going to tell us what our x-intercepts are. So if I take x plus 3 and set it equal to 0, if I subtract 3 from both sides, I know that one x-intercept is going to be -3. And then x minus 1 is equal to 0. Add 1 to the right-hand side, I get x is equal to 1 as my x-intercept. So these are my x-intercepts. And how that works in terms of graphing, if I separate this, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. This is just kind of a rough guess, rough estimate. Obviously, it's not very good, but it kind of gives you the same the overall idea. So I have two x-intercepts. What that means is 1, 2, 3. I know I have an x-intercept 3 units to the left of my origin, and I have an x-intercept 1 unit to the right of my origin. So those are my two x-intercepts. From there, I can actually find my axis of symmetry. And that's because my axis of symmetry is always going to be exactly in between my two x-intercepts. It's going to be directly between my 2 points, and I know that because my axis of symmetry is what cuts my graph in half equally on both sides. So if I walk my fingers backwards, if I go 1 unit to the right, 1 unit to the left, 1 unit to the right, 1 unit to the left, I know my axis of symmetry is going to go through the point, or the line, the point x is equal to -1, but it's going to be the line x is equal to -1. And that's going to be a vertical line. So that gives me my axis of symmetry. If I know my axis of symmetry, I know what my x value is on this line, which means I can find my vertex by plugging in x is equal to -1 into my original intercept form equation. And I do that by taking y is equal to -1 plus 3. I take -1 minus 1. And if I crunch those numbers, -1 plus 3 is going to be 2. -1 minus 1 is going to be -2. So I get y is equal to -4 when I plug in x is equal to -1. So I know my vertex is going to be at the point -1, -4. So if I count that out, 1, 2, 3, 4, I get my vertex. If I connect those 3 points now, because that's all I really need for my quadratic function, I'm going to end up with the exact same looking graph as I got here on the right-hand side of my original first page on my notes. So all three of these forms give you the exact same graph. So I just wanted to kind of go through what those three different forms were and kind of bring back some of that memory. So what I want you guys to do now is to stop the video. I want you guys to work on numbers 1, 2, and 3 that are given to you as practice problems on the front sheet. And then the next link to the next YouTube video is going to go over a couple more examples that cover factoring and finding square roots.